Shell sort is a generalization of the bubble sort and insertion sort. It compares elements that are distant apart rather than the adjacent ones. We can compare the values using a certain gap between two numbers. In each pass, we keep reducing the value of the gap until it reaches 1. In the last pass, the shell sort is like the insertion sort. The running time of shell sort is heavily dependent on the gap sequence it uses. So the formula for the gap is n divided by 2, where n is the number of elements. For example, if n is equals to 10, the first gap is 5, the second one is 2, and finally the last one is 1. So here's the first example. We have 10 elements and the gap is 10 divided by 2, which is 5. Since the gap is 5, we're going to compare the first number, which has an index of 0, and the second number, which has an index of 5. Just add the gap to the index of the first number so that you can find the second number. So let's compare 37 and 3. Since 3 is less than 37, they are going to swap places. Since they are now sorted, let's move on to the next number. 22 and 1. Since 1 is less than 22, they are going to swap places. The next one is 18 and 29. Since they are already sorted, we can now move on to the next set of numbers. 50 and 69 are also sorted. And lastly, 2 and 5 are also sorted. The first pass is now done, so we need to reduce the gap now. Since the gap from the first pass is 5, we then need to divide that by 2 to get the gap from 4 to second pass. By integer division, 5 divided by 2 is 2. Let's start with 18 and 3. Since they are already sorted, we can now move on to the next set of numbers. 50 and 1 are already sorted. 2 and 18 are not sorted, so we need to swap their places. However, we still need to check the number before 18, the gap of 2, which is 3. We can see that 2 is less than 3 and 18. So that means that we have to put 2 in number 3's position and 18 in number 2's position. After that's done, we can now check the next set of numbers. We can see that 50 is greater than 37. We also need to check number before 50. Since 37 is greater than 1 but less than 50, number 37 and 50 are the only ones that are going to swap. The next one is 22 and 18. It is already sorted. We then compare 29 and 50. Since 29 is greater than 50, we also need to check the other numbers before 50. We can see that 29 is less than 37 but greater than 1. So now we know that 29 will be in number 37's position and number 50 will take 29's original position, and 37 will take 50's original position. 69 is greater than 22, so it will just stay in place. Lastly, 5 is less than 50. We have to repeat the same process of checking the numbers before 50. 5 takes number 29's place, 50 will then take 5's original place, and so on and so forth. Lastly, we now need to sort elements with a gap of 1. Take 1 and 2 as an example. 1 is less than 2, so they switch places. This goes on until everything is sorted. The best case. The best case of the shell sort is where the elements of the array are already sorted. Take this for an example. We have 5 elements in the array that are already sorted. First, we start off with the normal procedures. count the elements, get the gap until it reaches 1. Here, we see that all these passes doesn't need to swap because of its arrangement, thus making it the best case. The worst case. The worst case, on the other hand, holds an array with elements arranged to a descending order. Here, we see that all the passes needs to swap the elements to its position, thus making it the worst case.